So the first thing I want to do, okay, is just quickly go over like 2 or 3 of these examples with the trig ones, okay? The trig ones, I know we all did them other ones yesterday, and I was very happy to see we did them well.
Yes, I did.
Here's what I want to go over. I want to start by looking at number 3. Well, here, I'll give you a hint. I'm not going to go over some of them, but I'll give you the u's for some of them. I'll do that much. For number 1, your u value should have been sine of x. Okay, figure out the rest on your own for that.
Oh, he's on the other one.
For number 2, I'm not going to go over that one either, but number 2, your u value should have been x cubed plus 1. Number 3, I'm going to go over real quick.
What's that?
Kenny, relax.
You can see it all day.
Now, here's what I want to go over for this one. Here's the reason why. First, go through your thought process. Imagine if u were equal to sine of x. What's the derivative of sine? Cos. Cos. And I don't see a cos here right away. So it's not going to work like this. Agreed, like this right now. Okay? Derivative of secant.
Tan.
1 over.
Cotan. Is it secant? Oh,
No,
no, secant tan?
Secant tan. Derivative of secant is secant tan. So if I have a secant tan here, well, secant tan might work. You never know. It could theoretically, because secant is 1 over cos, tan is sine over cos. So you get sine over cos squared. That might cancel. It doesn't work. We check in our head. So then we stop and we said we've exhausted all of our options so far. So now what is our next option?
Alternate. Make secant into 1 over cos.
Change something into what?
Or like,
Secant.
So what is secant defined as? 1 over cos.
8.
How much sharper on this laptop?
I know, right?
What's on my laptop?
It looks sharper on your laptop.
Yeah.
It's high def.
Let's just stay on task, yeah. So at this point, now I take a look and I say to myself, what is 1 to the 8th?
81.
This is 1, isn't it? Again, distribute the 8 to both of these people. What's 1 to the 8th? It's just 1. So you really don't need the 8 out there, actually. You could just put the 8 in here. Okay? But you can't just ignore that. You have to think mathematically where it comes from. Because if this number had not been 1, had been 2, and you had to put it to the 8th, it would have been 2 to the 8th. Okay, keep that in mind. Now, the next thing I say to myself is, now if I take the derivative of sine, I do get cosine, right? But I have 8 cosines, don't I? So is that going to work? So maybe I want to choose this whole thing as u. Okay, so u equals cosine to the 8th x. Well, the derivative of cosine of the 8th, that's 8 cosine of the 7th times the derivative of the inside. Another thing doesn't work. What's the last thing to try? Just cos x. So let's let u equal cos x. Therefore, du equals negative sine x over the dx there.
You can leave the 8 out? Like, do that?
Sure, because now it's if u is cos x, this, when I replace it, is just going to be u to the 8th. Because this is really to the 8th power. That's why I hate the way we write these. And it always shows that way. But I would write it this way. Doesn't that make so much more sense? Now it makes sense that if I put a u in here, it's u to the 8th. Okay? Again, I don't know why. Solve for dx. We get du over negative sine x equals dx. Okay? I know, it got worse. Sorry. And now we plug in. Let's go plug in. So, sine of x here, I have a sine of x here. Clearly it's going to. So I have integral sine x
1 over u to the 8th.
1 over u to the 8th. I'm going to show that though. Hold on.
Du over sine. Negative sine of x.
We all notice the negative, right? So bring it out front as a negative in the denominator. So the front becomes 1 over negative 1 now. But that's just negative 1. But don't forget that. This is in the denominator. Had it been a 2 here, it would be 1 over negative 2. So be careful. Since this is in the denominator, it really occurs in the denominator. Clearly we all know that that's just negative 1. So it doesn't affect this problem. But had there been a 2 here, it would be 1 over negative 2, which is really negative 1/2. Everybody understand that? Don't ignore that, please, because it happens to be an easy problem.
Is that a step that we have to do, though? Isn't it like implied?
You don't have to do that. You can leave the negative in the inside.
Negative will be dragged. Yeah.
Sure, and drag it along the whole way. Absolutely, Kenny, yeah. But I would do that, okay, just to be safe. It doesn't matter though. Doesn't matter. Signs cancel clearly, right? And now I have negative integral of 1 over u to the 8 du.
Plus C.
Okay? I didn't integrate yet. Plus c though next.
Sorry.
It's alright. Jump the gun. How do I write this?
You put it to u to the negative.
U to the negative 8. When I integrate, I raise the power. So what does negative 8 plus 1 become? Negative 7. Not negative 9, be careful. We're raising the power. So we're going from a more negative number to a less negative. So negative integral of u to the negative 7 over negative 7. Oops, sorry. No integral, sorry. Plus c.
Negatives cancel.
No.
Okay?
Actually, no, wait, yeah.
Are you okay back there? The negatives do cancel, yes. And notice, people, if I had extended my bracket over here, I would have to extend the negative, which would make this minus c. Doesn't matter. C is a constant. Whether you write it as minus or plus, it makes no difference, because later on you're going to solve for c if you're given an initial condition or a particular condition you develop what c is. So whether you put negative or positive, it has no effect on it. Okay? Leave it as positive, please, just to be safe.
Was I on the test?
No, but I'm just saying there's no reason to do it. So whenever you integrate, add on a plus c and leave it alone. Don't distribute whatever is out here to
I still love my somebody. Yeah, that's a hole in this room. That's my butter. Hope you enjoy it. Put the cheese stick in.
You did.
So, let's write our notes down as we do this. We'll talk. Let's write our notes down. First, the negative cancels, becomes a positive. I see a negative 7 in the numerator. Think of it as a positive 7 in the denominator. So once I take this and move it down below, I'm left with a 1 up top. Okay, I move that down below. I have the 7, u to the 7th. That's down below now, plus c. U was defined as cosine of x. I replace that. Since it's cosine of x right here, it's cosine of x to the 7th. So cosine 7x. The original problem, Jasmine, started cosine of the 8th. Yes. And then once we define u as cosine of x, we then just plug that back in. It became 7 because we integrated. Remember when we integrated, we got from negative 8, the integral of negative 8 becomes negative 7 over 7. So we then have to replace u with what we started with. U was defined as cosine of x, not cosine 8. Okay? Then we plug it in there. Okay? So this is our final answer here. Good? All right. It's the thought process that is important right now, guys. It's the thought process. Knowing how to go from problem to problem. You okay? For number 4.
Actually, I need to get a trigonometric sheet.
That's what we were
I need
talking
to
about.
make one of those.
I'm gonna print one out for you this weekend. I said, remember? Oh, you weren't here.
Nice.
I'm gonna print one out this weekend. Oh, you didn't watch the video, did you?
Oh.
Whenever you say something that I said the day before,
Come on.
I know you didn't watch the video.
Well, I didn't say I did.
Well, I said that in the video, so you would have known. Anyhow, this problem can be a little bit confusing. Okay? This one can be a little bit confusing. How come? How come this problem can be confusing was the question,
I
Terry?
don't know which one's the U.
Come on, you can answer that. Why do you think it's confusing? Why do people get confused by this problem? That shows that you really understand it, if you know why people get confused. I'm asking him, I'll come back.
All right.
Okay, because why? Good, because why? Is what?
It's logged.
No,
No,
no. What is it? The repeat function. E to the x is e to the x. It's an integral. As a derivative, it's e to the x. So it gets confusing here. Okay, it gets confusing. So my option for you guys is either to start with the denominator or the numerator. If they don't work, then go to the exponent. Okay? Just trust me. Let the denominator first. The reason I'm choosing this is because whenever I differentiate, it ends up in the denominator, doesn't it? And what's the derivative of 1? So that's going to drop off. This is going to become e to the 2x times 2. So you'll have an e to the 2x times 2 here. You'll have the e to the 2x up here. And they're going to cancel. So let's go ahead and do it.
It'll be hard if you never.
Why is it the times 2? What rule is that?
No,
Chain. The derivative of e to the 2x is e to the 2x times the derivative of the argument. The derivative of the 2x is just the 2. Derivative of 1 just drops off. So I resolve here. Please write it like that. Put the 2 out in front. It's the same thing. Everybody see what I just did? Move the 2 out in front, please. So rearrange, flip-flop our spots, and move the 2. So now over here, I've got the integral of e to the 2x over u, because that's what I define u to be, the denominator, times du over 2 e to the 2x. Kerry, what cancels here? Good, not 2, right? Good notice there. What happens to the 2? What do I do with it? As a what? As a 1/2, because it's in the denominator.
But it still stays.
Sure, Kerry.
It's 0.5.
What's the integral of 1 over u, though?
Ln.
Wow. Good. Okay, the integral of this.
Was that absolute value? Was that absolute value?
Really loud.
Let's see.
And what was u defined as in the beginning? U was defined as the denominator,
2x.
e to the 2x plus the 1. Don't forget the 1
Oh,
there.
I know.
So I go ahead and I say 1/2 e to the 2x plus 1 plus c.
That's the answer.
And that is our answer. Not that bad, okay? All it is practice for this. Just like the other techniques.
And knowing
Yep, thank you.
took a measure.
Unless you make a mistake like I did there. Don't forget the other. You gonna say the same?
You funny that was.
Where's him? What are you doing?
Maybe I'll just go party later. Yes, because definitely people keep going to this weekend. You're so far away now, you know?
Right?
All right, here's what I'm going to do. I'm going to post the solutions to other problems online. It's up to you to read it, okay? I'm not going to spend more time on it. Both. I always put everything on both. So check both, please. Or check one or the other. On both. Yeah, that's fine. All right, here's what I want to talk about. So let's go through the year and think of where we're at right now. Because next week is a week that I want to discuss with you guys what you want to do. Right now we have, well, obviously today is Friday. We have Monday and Tuesday next week, no Wednesday. We have Thursday and Friday. So we have 4 days of class. The end of the third quarter ends this day.
Next Friday.
Okay? Now, next Friday. So here's where we're at. We have still to do linearization and differentials. I'm going to write this down over here. Linearization and differentials, second time. And then slope fields, second time.
So then are we going to do the first of April?
I'm going to, let's discuss. I'm trying to outlay everything. Now, after that, we have our integral stuff to go through. Okay, so let's open the syllabus so we have it up so we can actually do this.
I need one picture of
Like the basic rules, basic rules, and then it's like the laws and stuff.
Yeah, and application. I mean, yeah.
right?
All right, ready? Next, introduction and Riemann sums. I still want to talk about trapezoidal. I'm going to do it during the review though. I'm going to do regular Riemann sums for your assessment. I'll talk about trapezoidal when we get into review month. Everybody hear me?
Yes.
So we'll just do Riemann sums. So that's one more to add. Riemann sums and then just general antiderivatives. So we've got
That's random. Nobody goes this way.
I did have it.
What are we in the 80s? Only people who are like hate the future go to those because they want to go back to the past.
Why do you call it basic? I think I got
what does this mean?
Independent.
Well, you give
Oh,
what are
given.
given?
You you're not giving C. I mean, you're not giving like the
So you have a C.
So you have a C.
I knew that.
Edgar.
Indefinite
So here, we have the first two topics. This was Riemann sums with the rectangles. You'll be given, I'll ask you to do either LRAM, RAM, or MRAM, and tell you how many subdivisions to do. We have to do first and second still. We haven't done any of these. Antiderivatives, which is just indefinite, which means it's the ones with no limits on the integral, and it's the plus C. Kind of like what we just did, but that was substitution method. We got to do 1 and 2. Okay? Which one? This one? Riemann sums, you're given the graph, you got to put the rectangles under the graph. Find the areas. Okay, next.
It's how antiderivative is just
Just a fancy word for integral. Indefinite integration. Next. Fundamental theorem. Fundamental theorem, all it meant was this. Remember that if I have an integral from 1 to 5, it could be 1 to 3 plus 3 to 5. That's what the fundamental theorem really says. Okay? And the integral of the derivative is the original. Think about that logically. If you have the derivative and you take the integral of it, you go back to the original because they're inverse operations. And definite integration. So you're going to see limitations, numbers. You have to plug in those numbers at the end, find the overall number. Okay? So fundamental theorem I'll put next. After that, average value.
Lysol, guys. Take my Lysol.
What does FTOC stand for?
But also,
Fundamental
Theorem
calculus.
of calculus. Very good.
also,
I've written it that way. I just thought somebody would know. Nice. FTOC, fundamental theorem of calculus. Next one was average value.
wait, there is a
FOTC, not R. Different
Does that
things.
anymore. Some preschool.
What was this one, guys?
The medium or like? Oh, we find a.
Good. What formula? What did we put in front of the integral?
Absolutely.
Nope. That was the distance displacement.
No, 1 minus
the-
B.
There you go, yeah, 1 over.
1 over B minus A. Remember 1 over B minus A? The example was this. Remember I said if you pour a glass of water and it's going to be all like, it's going to be all flowing, but eventually what happens to it? It settles out. It's like a graph when we were given like a curve like this, and I said to you, find a rectangle that would give the same area. Well, there is a rectangle somewhere here that gives the exact same area as the original. These are your overage, this is your underage, they balance out. That was the average value. After that, initial conditions of particular solutions. Initial conditions, okay, was when I gave you like f of 0 equals 2,
Yeah.
okay? And you were able to solve for C. This was all about solving for C here. You're given an initial condition like f of 5 equals 2, and you can take the integral and just solve for C. Now, what else did we do with this? Slope fields, part C.
Yeah.
Remember that? Remember? We did all that stuff with K and C, where e to the C is K and all that fun stuff. Natural logs kept coming up. That's what that is. Okay?
Who said fun? I didn't talk to you. Fun.
Like I did just now.
We have to do all of those?
Initial conditions. No, I'm just listing where we're at. Initial conditions and particular solutions. Remember, initial condition only occurs when it's f of 0. Initial. Anything else is considered a particular solution. What's that?
You never label your
Those-
What do you mean?
Like, you never put, like, you just say the top.
Oh, you gotta write the thing. It's not. If I say something, doesn't mean you don't have to write it. I'm not gonna write everything. Next one. Substitution is what we just did. Okay? We did this already, but this is application, so we'll hold off on that one for now. The distance versus displacement. So substitution. So let's discuss now.
You first, man. Take the first advice.
Here's what I think we should do, and then I'm going to give you alternates. Okay? I'm going to give you my suggestions, then I'll take your input. Clear? Okay, so I'm going to give you my suggestion first. Let me zoom out a little bit so you can see this better. Alright. So here's what I would like to do. Next week we have 4 days. We have 4 days. I would like to spend 1 day at least, just 1 day reviewing some of this stuff, for sure. Okay, I would also like you guys to take these two, the second try. So my thought was this. We take the second try of these two on Monday, okay, and then after that we just review for the rest of the period. This will take about, honestly, slope fields takes about 10 minutes maybe, 5 to 10. This one, I'm going to give you one with propagated error. I already told you that. Okay, it's going to take you maybe 3-4 minutes. That's all that should take. So these two problems are going to come on Monday. then we review. Again, this is my hypothetical. So problems, and then review. Now, when I mean review, I'm talking about reviewing these two things. Can we stop with the huffing and puffing back? The review is a review of integrals. So we have 6 topics here. Now, if we review on Monday, I think we should probably just take our assessments first. So take our assessments, not all of them, but maybe like, I don't know, 3 or 4 of them on one day. So assessments here. That's going to take us maybe like 30 minutes. Review again that day for the rest of it. Talk more about it. Take the other assessments, take the other 3 assessments, these 3 on this day. Review a little more. And then Friday, have just a test on integration. And we can worry about the second one after the test. It's up to you guys. We don't have to do this. Again, this is a hypothetical. Because a lot of people's grades are very low in here compared to what they want to be. And I know that. Okay, the last test, the grades were not high. The assessments for these, in general, are not high at all right now. Okay? I haven't graded the new ones yet, so they could change, but I don't suspect them changing in the positive direction. Okay? So I'm giving you an opportunity to possibly do this. Now remember, you can make all this stuff up still in the 4th quarter, and it'll retroactively change your grade. But what's going to appear in the 3rd quarter is what you see now, unless we take more assessments.
I thought we did 2 studies already.
So, again, hypothetically speaking, 3 integrals, the first 3, 3 more integrals, the second 3. On both those days, the time we have left, we'll spend other time doing more of this stuff. Then on Friday, have a test on integrals. And again, there's only like 5 topics, so this will not even be after school.
Yes.
We don't have after school on Tuesday this week. Oh, it's not us, thank God. We don't have after school on Tuesday next week. This will only be like 1 period test. Everybody clear on that?
Yeah.
Okay, if I want to, if I were to break it into 2 parts, I will literally make it 2 separate days. And then I'll extend the quarter until Monday of my grades. Our grades are not technically due until Wednesday of the following week. Okay, so not until the following Wednesday, that's when grades are really due. So I could really just extend it to Monday. So if it turns out that I really want to make it a 2-period test, I'm not going to make you stay after school or anything. I'll just push it to Monday instead. Okay? If you want to stay after school and do it then, I don't mind, but that's what we're going to do in class on Monday. So you'd be bored. So I'd rather you just do it on Monday. Other options. Now, I'll take hypotheticals if other people want to give other suggestions.
Have review on Friday and start the test on Monday and Tuesday.
No.
Have what?
Review Friday, start the test on Monday and Tuesday.
No.
I'm going to say no because I can't grade all your tests by Wednesday. That means I have to grade them the next day. That's going to put more pressure on me for the last day. It's not about that. It's just about the fact that there are other classes too. This is just one of the many. All my algebra 2 kids all do makeups on the last days. So I'm going to be sitting there doing a lot of grading for those.
Yeah.
And I give them that option. Okay? So I'm not going to push the test back there. What else? Do we want to just have a test and do something else these days and not do these assessments? That's another option. Or we could do this. We could do 3 of these the first time, then do 3 of these again the second time, and just have these 3 assessments done, but we've done them both to give you an option of having a 5. Because remember, you can only get a 5 by getting 2 4s. So no matter what, if we take all these once, nobody will have a 4. Nobody will have a 5. So if I give you these 3 on Tuesday the first time, and then do these 3 again for the second try on Thursday, that might be better. Because now you have a chance of getting a 5 on these 3.
So what about the test?
Okay? Still have the test on all of the stuff. We'll still have the test on all this because we're still reviewing on these days. Again, we're still reviewing on these days. I mean, a 4 is a 92 as your grade for an assessment. A 5 is 100. Okay? To get the 5, you need 2 4s. If nobody gets a 4 on these the first day, then nobody can get a 5 the second time. But I suspect almost everybody will get a 4 on this. It's a very easy topic. It's pretty much practice, guys. If you know how to draw rectangles and you follow the rules, it's very straightforward. Here, antiderivatives. You're just saying to yourself, what's the integral of something? That's it. Just remember the C. Okay, I might ask you a rule where it's like, if I go from A to B and then B to C, if I split up my integral, then I can put it back together. Like if I want the integral of 1 to 5, it's 1 to 3 plus 3 to 5. So rules might show up. But those are things that should by now be pretty straightforward. And then FTOC just means that you have an integral with the numbers on the top and the bottom. So you have to plug those in. It's pretty much the same thing as this. Say again?
No, I didn't know if FTOC
As direct, or as a definite. Yes. FTOC and definite integration.
And what are we doing Monday? Reviewing?
Monday was just reviewing in general, reviewing all the integral stuff.
Okay.
Tuesday was taking the first 3. I mean,
How long do you?
we could take all 6 on Tuesday, then all 6 again on Thursday, then the test on Friday.
I like to
You're like a pro by the end of it.
Why we can do it twice.
That's kind of true, but, or we could suck completely across the day.
But if we're reviewing them all the first day,
Be a pro.
then we wouldn't have any review time those days.
We can do 4 on Tuesday.
So here's the options. Here's the options. And I'm going to take a vote. Democracy is the easiest way. Okay? 2 options right now. This will still be the test. This will still be the review. Here's the option now. Either, and you don't need to voice yourself. We're just going to vote. So use your own opinion. You don't need to coerce others. We're going to say either these 3 on both days, so twice, or these 3 on day 1, and these 3 on the other day. So again, in that order. The first option is doing these twice. Can I not write over here?
Yeah.
Weird. Doing those twice. The second option is doing these 3 and then doing these 3 on the other day. So splitting them up and doing them all and then having the test. So hands for option 1, doing these 3 twice.
Wait, what's twice again? What's on the same day?
Okay? Hands down. Hands for doing these 3 on the first day, then doing these 3 on the second day.
Counting my hand, right?
For some reason I got lost with this.
Houston,
That's the choices.
what's your vote? Do you know what you're voting on?
No, I don't. I heard Easter.
Either way, we had 6 for the first vote, and even with Houston's vote, it's 4. Somebody clearly didn't vote, and Jocelyn's not here.
I didn't vote.
I agree to vote?
He
put his hand up for the first one.
Yeah, so you lose, man. There's no, I'm gonna wager my vote. People get to, pay me off for my vote. You don't get a vote. So what we're doing is twice of this, okay? We're just taking a vote, guys. So we're doing, again, just to go over the schedule, to make it easier, a little clearer. Where's the Zoom?
What is it? Like, you just need one problem is practice enough. So it's really short. Can you deck on your are you ready?
Yes,
So next Monday,
maybe.
so Monday we're gonna review.
Linearization and subfield, we're gonna have those, and then we're gonna review for the, yeah.
We have the right concepts.
So linearization and differentials, second try, review. First 3 integrals, 3 times, okay, or sorry, the first time for the first 3 integral problems, and more review. Those same 3 again for the second try so you can get your 5s on them, and then review. And then the last day, test on integrals. And again, no matter what, guys, whether we do the first 3 or the last 3 there, we're still going to be reviewing all of them for the test. This is not review only the first 3. We're reviewing all the stuff for integrals for the test. So these 3 half review days, because they'll pretty much be half a day review, half day review, half day review, are all going to be for all integral stuff. The first 3 integration ones, twice. Okay? So it's going to be Riemann sums, it's going to be indefinite integrals, and it's going to be fundamental theorem. If I'm correct, let me just go back and check. First 3. Yeah, average value is the next one. So we're looking at these ones right here. Riemann sums. Did I write that much all over here?
Yeah.
Hey, you're like.
Riemann sums. Good thing I don't print it out.
You're like a little child trying to color in the line.
Riemann sums, antiderivatives, indefinite. This is good that we grouped it this way, actually, because these are all very similar. This has to do with the area under the curve, which is the integral, which happens to be a definite integral also if we want to do it. And then we start looking at a little more of like difficult stuff, average value, initial conditions, substitution. So it's probably good that we actually did it this way. Okay?
Question.
Back to-
For now, we move, we change, before
Go, go, go. Come on.
the first 2, linear and slope field, did you say you wanted to put them in somewhere, or we're not going to do the entire
Wait,
thing?
Kenny.
We're doing
Monday.
Monday.
Okay. These are review though. It's not.
No. This is review of integrals. We're taking those assessments.
There we go.
Second try of those assessments, that's review.
So
Separate.
I asked before we did Monday, you said review.
Okay, but I also said those. Everybody else heard it. So
What?
you must have just missed it. It's okay. Linearization, differential, slope fields, then review. It's why it's a half day. Here, 3 integration, review. 3 integration, review, test on integrals, and then if we split the test up, I might put more on the next Monday.
How bad are our grades that we didn't do this?
We don't have to. I'm just trying to get you guys, so we're kind of done with our assessments too. So as soon as we're done with integration applications, we can take those assessments, have a test, and then just review. All we got to do left is volume, that's it. That's really all we got to do, guys. Okay, if we go back and look at our syllabus now. Okay, this one, I'm sorry, we're going to do this, but this will take us like literally 20 minutes. It's one of the easiest topics there is. If you can do an integral, you can do this. That's all you have to think about. Okay? If you can't do an integral, then that's another issue. You got to go back and study more. Watch some videos. We did this already. Okay? We got to do these two. These are the toughest ones by far. But we're able to make some objects and make it easier. It's very real life. All right, you got 15 minutes to relax.
Oh, wow.
I rarely do that, I know. My voice needs to slow down for a little. Just get my throat.
What? I have 2 next Sunday.
Give me like a 5 minute.
Give me a favor.